Okay, so note 6 is over factoring trinomials when a is equal to 1. So remember I talked about yesterday everything that we were doing with taking out the GCF and learning how to factor out binomials was going to help us to the big topic here, which is factoring trinomials. Okay, so this is separated into two notes. So note 6 is going over when a is equal to 1, and I'll talk about what I mean by a in just a minute. And then the next note is going to be when a is greater than 1. Okay. So factoring trinomials with a leading coefficient of 1. So remember that standard form of the quadratic equation is ax squared plus bx plus c. Okay. And each of these values, a, b, and c, are numerical values. Okay. So when we look at all these equations, they will always be set up where x squared is first, the x is in the middle, and then our constant number is at the end. Okay. So for all of these ones, you'll notice that there is not going to be a number in front of x squared because this is only when a is equal to 1. And we don't need to write that invisible 1 here. Okay. So starting with this equation, our goal here to factor it is to first identify a, b, and c. Okay. So we know a is 1, b is going to be 4, and c is going to be negative 45. So it's going to be the sign attached to it, so negative 45. Okay. To solve these, we need to find two numbers that multiply to c but add to b. So we're going to find two numbers that multiply to c and add to b. Okay. So in this case, our c value is negative 45 and our b value is 4. So I need to think to myself, okay, what are all the numbers that multiply to 45? So we have 1 times 45. Any others? 9 times 5. Okay, so we can do 5 times 9. Anything else? 3 times 15. Okay, and I think that's it with the factors. So these are all the numbers that multiply to 45. Since this is a negative 45, that means this first number could be negative or the second number could be negative. It really just depends on what we're needing. And then this next part is we need to check if we were to add any variation of these numbers together, would we get 4? Okay. So remember, one of these have to be negative. So if we look at 1 and 45, let's say the 1 is negative. Well, what's negative 1 plus 45? 44. So that's not equal to 4, so that wouldn't work. Okay, then I test my negative on the 45. What's 1 minus 45? Negative 44, so that one does not work. So I cross that one out. That one would not give it to me. And if you need to write it off to the side, you can say, okay, we did negative 1 plus 45, and then we did 1 minus 45. And neither of those gave us our value of 4. Okay, then we check the next one. Okay, let's make 5 negative first. What's negative 5 plus 9? 4. Okay, negative 5 plus 9 is equal to 4, which means that negative 5 and 9 are going to be our factors. We don't need to continue once we find our answer. So then we're going to take those factors and we're going to do our 2 parentheses. Okay. In each parenthesis, we're going to put an X. Okay. And then in the space next to each of the x's are going to be the numbers or the values that we found that work. So -5 and a +9. And that would be my answer. So x minus 5 times x plus 9. Okay. So let's try another one. Okay, so first labeling our A, B, and C. What is A? 1. Remember, it's always the number in front. Okay, and if we don't see a number, we assume it's 1. What is B? -5. Remember, it's only the number. And then what's C? -14. And I'm putting those there to remind myself it's not just 5, but -5. And it's not just 14, it's -14. Okay. And then I write my C value, which is -14. And then I write my B value, which is -5. And I'm trying to find two numbers that will multiply to -14, but add to -5. So first, I think, okay, what are the factors or the numbers that multiply to 14? So I have 1 times 14. Any others?
2 times 7.
2 times 7. And I think those are the only two. Okay, and since it's a -14, we have to give the negative to one of those values and then add. So -1 plus 14. Does that give me -5?
No.
No. Then I do 1 minus 14. Does that give me -5? No, so it's definitely not these two. Okay, then I check the next one. -2 plus 7. What does that give me? +5, so that can't be our combination. So I check the other way. 2 minus 7, -5. So 2 and a -7 are going to be my factors that work. So I go and I write my two parentheses. What is going to go into each parenthesis?
X plus 2, x minus 5.
Good. X plus 2, x, not -5, but -7, right? These ones that we found worked over here. Okay, so that's where that +2 went and where that -7 went.
So it doesn't matter the order?
Doesn't matter the order. Nope.
Like, so if you put the x minus 7 first, it would still be right?
Correct.
Oh.
Correct. Okay. So yeah, it doesn't matter the order you do this. So if you wanted to have x minus 7 and then x plus 2, it's still the same thing because we're multiplying, right? So if you're multiplying, let's say you have 2 times 5, okay? Is that the same as 5 times 2? Yeah, they're both equal to 10. So it doesn't matter the order. Okay. Okay, so our first step is again to label A, B, and C. So what is A? 1. Remember, it's always the number in front. So for these notes, A is always going to be 1, but we just want to get in the habit of labeling A as well. What about B? -15. And then C? 50. Good, +50. So then we need to find two numbers that multiply to 50 but add to -15. So then I start thinking of all the numbers that multiply to 50. So I have 1 times 50. Any others? 2 times 25.
5 times 10.
5 times 10. Good, you can make them both negative, and you could say -5 times -10, okay, because to get a positive number, it could be 2 positive numbers or 2 negative numbers. Okay, good. So just looking at these factors, we think, and we start adding them together. Well, 1 plus 50 doesn't give me -15, and then I make them both negative. -1 minus 50 also doesn't give me -15, so it's not this one. Then I do the same. 2 plus 25. Okay, that's 27, so that doesn't work. And then I do -2 minus 25. Make them both negative, and that's -27. Again, doesn't work. Okay, then I check the last one. So 5 plus 10 is 15, so we're getting closer. And then we check when they're negative. -5 and -10 gives me -15. So that means -5 and -10 are going to be the numbers that I plug in to my parentheses. And so what is going to be in my parentheses?
x minus 5 and x minus 10.
X minus 5, x minus 10. Okay, so in this example, what is my A?
1x squared.
Remember, it's only the numbers, so A is just 1. Okay, what is B? -16. And then C? 48. Okay, so two numbers that multiply to 48, but add to what number? -16. Okay, so then I start thinking of all of my factors of 48. So I have 1 times 48,
8 times 6, 4 times
8 times 6, 4 times
2.
12, 2 times 24. Is that all of them? Sorry?
8 times 6.
8 times 6?
Not 8
3 times 16.
Oh, 3 times 16. Okay. Thank you, thank you. Okay, so we have all of those. And now instead of going through every single one this time, just looking at them, can we maybe take a guess at which one would get us to -16?
-4 minus 12.
Good. So if we look right here at the 4 and the 12, I know that if I add that together, I'm going to get a +16. Which means if I just make both of them negative and I add them together, I'll get a -16. So -4 minus 12 equals -16. So those would be my factors, a -4 and a -12. Okay. So what would be in my parentheses?
X minus 4
Mm-hmm.
and x minus 12.
Good, x minus 4, x minus 12. And then in this one, before we continue, I want to show you that you can actually FOIL these terms together to check your work. Because if you FOIL them back together, so multiply them back together, they should end up with the original equation. So for this one, we're going to check our work. And so I'm taking x minus 4 times x minus 12. And has everyone heard of FOIL method? Okay. Yes, okay. So FOIL method just it stands for something. You don't need to know really what it stands for. Just know that you're taking the first term, whatever that first term is, and you're multiplying it in. So you're taking that first term and you're multiplying it into each of the terms. And then you take the second term and multiply it in. Okay. So following the red arrows first, I have x times x, which is
X squared.
x squared. And then I have x times -12, which is
-12x.
-12x. I just put them together, the number and the variable. And then following the blue arrows, I have -4 times x, which is -4x. And then -4 times -12, which is +48. So if I'm to combine like terms, that would be these two middle terms, I would get x squared minus 16x plus 48, which should match exactly our beginning equation. Okay, so again, this is a way to check your work. Say you're not quite comfortable with your answer and you want to make sure your answer is correct. Then you go back and you FOIL those two parentheses together and see if you get the original equation. Okay, any questions so far? Making sure everyone's done writing.
How's it doing my input today?
Okay. So before we move on to the next part, notice at the bottom I put some rules for factoring trinomials. So in these rules, and you've probably noticed them as we were already doing some of these examples. Okay. So the first rule is when c is greater than 0. So what that means is that last value at the very end is a positive value. So if it's a positive value, then you know that within your parentheses, you're going to have the same sign. So they're either both going to be positive signs or both going to be negative signs. Okay? Which makes sense because if this is a positive value that we're trying to multiply towards, the only way to get a positive number is multiplying two positive numbers or multiplying two negative numbers. Okay. And then the other case here is when c is less than 0. So it's talking about that last term there is negative. Well, if the last term is negative, then you know your parentheses are going to have different signs. Okay, meaning one will be positive and the other will be negative, or vice versa. Okay, depending on what it's asking. Okay. And that is because that c value we're trying to multiply towards that, and the only way to get a negative is to do a negative times a positive. Okay, so it says when factoring trinomials, you may need to rewrite it as ax squared plus bx plus c first, and or factor out a GCF before continuing. So if it's not in the correct order where it's x squared, then x, then our number, then we have to first write it in that order. And then if we see higher values, let's say we see values higher than squared, then that tells us we need to take out a GCF first before we can factor. So for example, looking at this one, is this in the proper order? No. So how would I write this in the proper order? P squared, negative 8p. And negative 48. Okay, now it's in correct order, so I can label my A, B, and C. So here's A, negative 8 is B, negative 48 is C. And then off to the side, I need to make sure I have two numbers that multiply to what number? Negative 48, but add to negative 8. Remember, don't forget about that sign. Okay? And we kind of wrote down all of the variations of 48 in a previous part. So if you wanted, you wouldn't have to recall every single one. You could rewrite what we wrote. So we have 1 and 48, 2 and 24. What were the other ones? 4, 12, 3, 16, and 8 and 6. Okay, so looking at those, we know one of them has to be negative. Okay.
4 minus 12.
4 minus 12. So it's going to be these ones right here, because if we try to add or subtract any variation of the other numbers, we're not going to get to 8. The only one that will work is if we do a positive 4 and a negative 12 will give us a negative 8. Okay, so we're using a positive 4 and a negative 12. In the parentheses here, am I going to put x like before? I'm going to do p. Everything's in terms of p now. So my first parentheses is going to be p plus 4. And then I'm going to have p minus 12. And that would be my answer. Okay. Now let's see this one right here. So the first thing you should notice is that there is a higher exponent here, which is t cubed, okay? Which tells us we need to factor out a GCF. But before we do that, let's go ahead and still put this in correct order. And the correct order is always going to be the one with the highest exponent first. So 10t cubed, and then what would be next? Minus 30t squared, and then the minus 40t. So this is now in order from greatest exponent to least exponent, okay? And then we have to see, okay, can we take out a GCF from this whole thing?
10t.
Good, 10t. And remember, GCF means you're looking at all the numbers first. Okay, so we said the largest number we can take out of all three of those is going to be 10. And then we look at all the variables. Well, the most t's that we can take out of each one is just going to be 1t. So our GCF is equal to 10t. Okay. And remember, when we take out a GCF, we have things left over in our parentheses. So we have 10t, and then we have these parentheses. And we have to see what's left over after we take out a 10. So divide each by 10, and then take away a t. So what's going to be left from the first term? T squared. Good, because 10 divided by 10 is 1, and we don't need to write 1. Then we do the next part. Negative 30 divided by 10. Negative 3. And then t squared, take away 1t. Okay. And then we do negative 40 divided by 10. Negative 4. And then if I take away a t from 1t, is there any t's left over? No. So this is what I have so far. Okay. Notice when I took out the GCF of 10t, I am now left with something that can be factored. I can now identify my A, B, and C. So that's what I'm going to do next. So I wasn't able to start my process until I put everything in order and took out a GCF. So I need two numbers that multiply to negative 4 but add to negative 3. The factors for 4 can be 1 and 4 and 2 and 2. So which ones would we use, and how would we get negative 3? 1 and negative 4. Perfect. So 1 minus 4 gives us negative 3. So we're using 1 and negative 4. Okay. Since I have a GCF, I need to make sure I bring it down with my answer. So I still have that 10t there, and then I do my two parentheses like normal. So what's going to be in the first parenthesis?
X plus 1.
X or t. Good. T plus 1. And then the next one?
T minus 4.
T minus 4. So this entire thing here is my answer. And by just doing this example, this is the, I would feel like the hardest we got in this notes. Okay, we've made it all the way up where we can do all the steps to factor when a is equal to 1. So that this would be as hard as this notes gets. And then we'll do a different process when we do when a is greater than 1 tomorrow. So we're going to do the same concept again. Okay. So go ahead and take a minute and try this one first. Okay, this one you need to make sure you put everything in order, then factor. And then if you're finished with this one, go ahead and try the next one as well. That way you're practicing one of each before we go over them. About one more minute to try to finish up these 2 questions. Okay, so I'm going to go ahead and go over this one first. And then I just want to make note that there are so many processes or techniques that you could have learned how to factor. So let's say you remember this skill from high school and your high school teacher taught you differently. Feel free to use that way to solve. I know there's so many different ways. There's the diamond method, the box method, the swing method. There's so many different ways to teach this. I'm just teaching it very basic, no fancy methods. Just because they're not going to do, they're not going to want those methods in college algebra. But let's say you've tried this and you're stuck and you just don't understand, feel free to go back to any method you have already may have already learned.
Wait, you said this is the method that they want in college algebra?
So in college algebra, you're not going to do this type of factoring. It will be more of the next notes. And on that next notes, I'm going to show you exactly how they want it. Okay, so for this one, we should have rewritten this as w squared minus 5w minus 6, which means our a value is 1, our b value is negative 5, and our c value is negative 6. So we would need two numbers that multiply to negative 6 but add to negative 5. And what were those two values? Sorry, say that one more time. 2 negative, well, no, 2 and 3 couldn't work because it has to be a negative 6. So let's say we had 2 times 3. That means one of them would have to be negative, okay? So the 2 and the 3 wouldn't work. What's another factor of 6? 1 times 6. And now let's make one of those negative to get negative 5. Would it be the 1 negative or the 6 negative? The 6. So this is 1 minus 6 equals negative 5, which means our factor should have been 1 and negative 6. Okay. So when you wrote your answer, you should have had w plus 1 times w minus 6.
Wait, why can't you do the 2 and the 3?
So let's say we tried the 2 and the 3, and I'll try it down here. In order to get a negative 6, one of them has to be negative. So I have to either do negative 2 plus 3 or negative 3 plus 2. And if I do that, you'll notice we'll get 1 or negative 1, which wouldn't work. It would be different if it was like a positive 6. Then you could use 2 and 3. Okay, and then the next one, we should first wrote it in order. So 2y to the 4th plus 30y cubed plus 112y squared. Then we should say, okay, I know I need to take out a GCF. What is that GCF? 2y squared. Okay, then I write my parentheses and I divide each term. So I do 2 divided by 2 is 1, but I don't need to write that. And then I have 4 y's and I'm taking away 2 y's, so how many do I have left? 2 squared, so y squared. And then I do 30 divided by 2, which is 15. And then how many y's are left over? 1 y. And then I do 112 divided by 2, which is, you said 56? Okay, 56. And then if I take out 2 y's from the 2 y's already there, they're gone. Okay? So this is what I end up with after taking out the GCF. Okay? Now I go ahead and label my A, B, and C. And then from here, I know I need two numbers that multiply to what? 56. And add positive 15. So what are those numbers that multiply to 56? 7 and 8. Okay. 7 times 8. And is 7 plus 8 15?
Yes.
So 7 plus 8 equals 15, which means our numbers are going to be 7 and 8. So I bring down my GCF, so 2y squared, and then I write my 2 parentheses. And what's going to be in the first parenthesis?
Y plus 7.
Y plus 7.
And y plus 8.
Y plus 8. So that means this whole thing is my answer. Okay, very important that you bring down the GCF always, because if you forget this step, then your whole problem is going to be wrong. Okay. Any questions so far? Okay. Okay, so now let's look at this one. Looking at the order first. Is it in the correct order? Yes. Okay, now we have to look and make sure that there isn't anything in front of the A. Is there something in front of the A? Or sorry, the A squared?
-1.
There's a -1 there, which means we need to take out a GCF of -1 in order for us to do our factor properly. Okay, so my GCF is -1. So if I take out a -1 from the whole thing, that means I'm just changing the signs. So now I have a positive A squared, a -6A, and a positive 8. So all the signs just changed. Okay. Now I'm able to identify my A, B, and C and start finding my values that will multiply to 8 and add to what number? -6. -2. So 2 and 4 are numbers. They both need to be negative. So -2 plus -4 gives me -6. So yes, -2 and -4 are my numbers that are going to go inside the parentheses. What's the thing I need to make sure I bring down? GCF, that -1. So then I have my 2 parentheses. And what's going to go in the first one?
A minus 2.
A minus 4. And that whole thing is my answer. It would even be okay if instead of -1, you just put a negative sign. That would also be correct. Okay, so you could put a negative sign or a -1. Okay, so now this one is adding in another variable. And what I want you to do is I want you to ignore that variable. So since we have c squared first, okay, I'm just going to assume c squared is my main variable. And so for now, I am ignoring all of the d's. Okay, I'm not saying they're gone. We're just going to ignore them for now. Which means I have -2c squared minus 22c minus 60. Okay, so everything is in the correct order, but there's something in front of c squared. So what do I need to do? Take out a GCF, and what would that GCF be? -2. So it'd be left with c squared, and then what's -22 divided by -2?
11.
+11. And then -60 divided by -2?
+30.
+30. And so now I have my A, B, and C. Okay. And then I am going to find two numbers that multiply to 30 but add to 11. What would those two numbers be? So if we can't think of any, we just start listing everything we know. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. Now looking at those numbers, any of them stand out? 5 and 6. Because if we add them, we get 11. So 5 plus 6 equals 11. So we're using the numbers 5 and 6. So I bring down my GCF, that -2. I do my parentheses. And in the first parenthesis, what am I going to have? C plus 5. And then in the next parenthesis, C plus 6. Okay, and remember I said don't forget about the D's that we crossed off in the beginning. Well, the only thing you're going to do is you're going to bring them down and you're going to put them next to the numbers. And then that's your answer. It's a lot easier doing it that way, ignoring them in the beginning and then bringing them down at the end, than it is going through the whole thing and saying, okay, I need two numbers that multiply to 11D, or sorry, 30D, and then add up to 15D. Okay, it's a little confusing that way.
Is there a reason why we just ignore them to the very end?
To me, I think it's easier. You don't have to ignore them. You could continue on, and what would happen is that you would have a D in each of these, which means you would have to find a number that multiplied to 30D squared and then add to 11D.
Yes.
So then you would be, okay, it's still 5 and 6, but it's 5D and 6D. So I only say take it off in the beginning because I think to some it could be confusing. The only issue with that is you need to remember to bring it back. Okay, so that could be the only issue that could happen if you forget to bring it back into your answer. Okay. We don't typically see ones like this. Okay, this is just testing our skill. Okay. Okay, so looking at this one, what would I have to do first?
The GCF.
GCF.
Out of every.
Good. I would take a -1 out of everything, which changes the sign. So I now have a positive x squared, a negative x, and a -12. So this is my A. And then what's my B since there's not a number there? -1. So -1 is my B, and then my C is -12. So I need two numbers that multiply to -12 but add to -1.
3 times 4.
3 times 4, which one's negative?
The 4.
The 4, right? 3 times -4. That gives us a -12, and then 3 plus -4 gives us -1. So 3 and -4. So I bring down my GCF and I do my 2 parentheses. Okay, and what's going to be in my first parenthesis?
X plus 3.
X plus 3. And then in my next parenthesis,
X minus 1.
x minus 4. And that whole thing is my answer. Okay. So in this one, I'll go ahead and show you what it looks like if we don't cross off the other one and we bring it with us the whole time. And then you can make the decision for yourself which method you like to use. Okay, so first, before we do anything, notice we have a number in front of a squared, which means we need to take out a GCF. And what would that GCF be? -3, so it can't be A because they don't all have A. So only -3. So we're left with A squared, and then what's 15 divided by -3?
-5.
-5, and I bring down the AB. And then what's -12 divided by -3? Negative or positive 4? Positive, because a negative divided by a negative is a positive, so positive 4b squared. Okay. Then I go through and I label my A, B, and C. So my A is 1. This is where it starts to get tricky. If we're going to include that second variable, then my B value is going to be -5b. Okay. And then my C value, sorry, this is B is equal. My C value is going to be 4b squared, the entire thing. Okay, because A right now is my variable. A is our x, right? So we're not going to count that. So then off to the side, I have to think, okay, I need two numbers that multiply to 4b squared, but add to -5b. Then I have to think, okay, what are those numbers? So what are some, think of just the number itself. Think of 4. Okay, so we can do 1 times 4. Is there a way we could alter these to get negative 5 when added?
Yeah, -1.
Negative 1 and negative 4, right? They would both have to be negative, okay? But we don't just have numbers here. We have that extra b. So this would be 1b times 4b, because that would give us 4b squared. Which means if we make them both negative, this is negative 1b plus negative 4b gives us negative 5b. So these are the numbers that we are going to place inside of our parentheses. So then we have negative 3 bringing down our GCF. And then in the first parentheses, we're going to have a minus 1b. What would be in the second parentheses? A minus 4b. Okay, it gets us the same result at the very end, but you choose if you like this method or like the method of forget about the b, come back and bring the b back down.
I like that one.
So whichever one calls to you, whatever speaks to you, right? Whatever is easiest. Okay. To me, I feel like this can get confusing with the extra letter. Okay. So last part of the note is prime polynomials. So it says sometimes when you try to factor, you may not get any factors of c that add up to b. In this case, we say that the trinomial is prime. For example, if we are looking at this one here, okay, so we label our a, our b, and our c. We need two numbers that multiply to 14 but add to negative 13. Okay, so let's pretend we don't know this is going to be prime. Okay, and let's genuinely see if we can find two numbers that will give us that negative 13. So we know 1 times 14 is 14 and 2 times 7 is 14. And then of course we know that we can also make both of those terms what? Negative. Okay, so we could try a negative 1 times a negative 14, a negative 2 times a negative 7, right? We turn them both negative.
I have a question.
Yes.
How come we couldn't just do that on this one? With the 1 and 6, when it was the 2 and 3? How come we couldn't just make the...
Because if we made them both negative, then that would be a positive 6. And we're in.
It's adding up?
So like if you did negative 2 plus negative 3, that would give your negative 5. That's correct. But if you multiply negative 2 times negative 3, then that gives you positive 6, and we wanted negative 6. Okay, so that's the reason for that. Okay. So again, looking here, if we were to add each of these together, let's go ahead and just try that out and see what we get. 1 plus 14 is 15. 2 plus 7 is 9. Negative 1 plus negative 14 is negative 15. And then negative 2 plus negative 7 is negative 9. This is just to show you we tried all the different numbers that multiply to 14, tried all the different ways to add up. Did we ever get negative 13? Which means that I wouldn't say it's not impossible. We're just going to have to use a different method to solve that, and that's a different notes. Okay? So for now, with what we already know and what we've learned, we just say, okay, I can't do this, so it's prime. But don't worry, we're going to learn about the quadratic formula, and you'll be able to do that to solve any type of trinomial. Okay, but with our current knowledge, we can't solve it. Okay, so again, we do the same thing. We say A, B, and C. And then I look, okay, two numbers that multiply to 28, but add to negative 7. Okay, and I start thinking to myself, okay, maybe I don't know this right away, but let me start looking at all the factors. So 1 times 28, 2 times 14. Any others? 3 times, no, I think that's 24. 4 times 7, and that's probably the last one. Okay, so we would do the same exact process and see if we were to manipulate these 3 factors in any way, would we be able to add up to negative 7? Well, if we just add these ones across, we get 29, 16, and 11. And then since this is a positive 28, we can also try the negatives of each one. Okay, but all that is going to do is just going to change all of these numbers here negative. It's just going to be negative 29, negative 16, and negative 11. So do any of those give us negative 7? Nope, so then our answer is prime.